I'm going to show you how to bring your architectural models into a 3D Google Earth map within Unreal Engine 5. You will be able to take any model from Revit, Rhino, or Sketchup and insert it anywhere in the world within your Google Earth tileset. The advantages, as you can see, are that you have satellite accurate massing at your disposal and can very quickly drop any design into this context. Plus, you have the full power of Unreal Engine 5 at your disposal. In addition, you can create animations, assets, materials, data overlays, and even first-person walkarounds if you wish. This is all now possible through the plugin Cesium within Unreal. Cesium is a platform for 3D geospatial, which lets you work with geospatial data, including 3D data tilesets, for both web and gaming engines. This now includes the Google Earth datasets, which was released quite recently and we will be using. We'll start by setting up Cesium for Unreal Engine. First, you need Unreal 5 installed, and within the Epic's Games Launcher, go to the Marketplace and search for Cesium. Then click on this. Currently, it is only available for version 5 and 5.1, so install it to one of these engines for free. I have already installed it, so I'm using version 5, and I'll launch a new project on Unreal 5. I will select a blank architectural project template, give it a name, and let everything compile. Next, I will install some plugins. So go over to the Edit and then Plugin. I'll search in for Cesium, click the checkbox, and restart Unreal for this all to take effect. I will also now mention that there are a lot of good basic tutorials on the Cesium website if you get lost. This covers the basic setup, connecting to Cesium, and how to work with the Google Maps API, although I will guide you through these next steps to make it easier. You also need a Cesium Iron account to access the Google Maps tiles, so head over to the website and you can open a free account if not for commercial use. I will create a new empty level here. Once that loads in, I'll go over to File and then Save and give it a name. And on the left side, there will be a Cesium panel, where I'll click and add Cesium Sun Sky, Dynamic Pawn, and a blank 3D tileset. So first off, the sky is completely blown out by default. So you have to go over to the Cesium Sun Sky and select the directional light, which is stacked under this. The intensity is set on a huge value, so just change this to a low value to bring back the sky. If you go to the Cesium 3D tileset over here, you see there needs to be an API access token. If you want to use Google Earth, you need to go to the Google Cloud Platform service and set up an account. Agree to the terms, and you see that you can try it for free and receive here $200 a month to use. So that's enough to play around with at the start with the Maps API. You see here also at the top that it says that it's for free, but you need a card for verification purposes, and you won't be charged until you manually upgrade to a paid account. So click Continue, and an API key will be automatically generated. You can copy this and save it, as it will be needed as a token within Unreal. Don't share this, otherwise all your API data may be used by someone else. You will then be taken to the main dashboard, where here under Credentials, you can see that the API key has been made, and you can change security settings or reveal the key again. Also, an important step is to activate the Map Tile API, otherwise it will not work. So type in Map Tile in the search bar, click Map Tiles API and make sure the API is enabled. Back over in the Unreal Engine, go to the Cesium 3D tileset and make sure source is set to from URL and paste in the API token here. Also, be sure to paste in this web link at the start of the API key. You can get this URL from Cesium web guide, but I'll also paste that link in the description below. Also, don't forget to actually connect your Cesium Iron account over here on the far left. You would then have a map generated, but we don't want it on a random location, of course. With this in mind, we need the longitude and latitude coordinates. And to get this, there are a number of ways. First, you could simply go to the Google Maps and type in the location. So I will want to locate my project in Shinjuku, Tokyo. Here's a nice fact. It's the busiest station in the world, with 3.6 million people passing through daily. You can also right-click on any point and copy the coordinates on any marker. Alternatively, if you want more choice, you can go to the OpenStreetMaps nominatum. Type in the location again to zoom into the region we want. Then hit the reverse button at the top. This lets you click on any location and you'll get the longitude and latitude of any point. It doesn't have to be in any icon, so once you pick a spot, just copy the coordinates. Over in Urneal, go to the Cesium georeference, and in the details you can see the origin, lat, and non. So make sure you paste them in the right order, and the map will move straight to your location after a few moments of loading. There is one more setting we need to check. Go to the Cesium 3D tileset, and in the georeference section here in the middle, make sure the Cesium georeference is selected. Everything went black, as I haven't set the time zone yet for Japan. So at the top, we could just select unlit for now, so we can see the geometry. You can see the huge sprawl of Tokyo below, and now I can pan around as normal. You can use the WSAD keys to move around, and the Q and E on the keyboard is to move up and down, which is very useful. I will zoom down to beside Shinjuku Station, and between the park and the site, I will place my architectural project here in this triangle. As you can see, the tileset is massive, and it will use a lot of data from the API, so we can reduce the city by using a clipping polygon. Before that, I'll create an object to help locate our site better in the future, and not get lost in a massive map. Click on Place Actors, Shapes, and then click and drag on a cube onto the map. If you press F on the keyboard, you can now zoom straight to our site. Also, if you select the cube and under Transform, right-click on the location and press Copy, it will copy to the clipboard or the coordinates. Next, in the Cesium panel on the left, you can click on the Cesium cartographic polygon. This will create a rectangle randomly in the center. However, we have saved our site coordinates, so you can go to the polygon transform and paste the location coordinates into here. So now you can see the clipping plane is centered on our site. Also, within the rectangles transform, you can change the scale to fit as much as you want of the site. So you can just zoom out and you can see where you want the placement of your context, bearing in mind which views you're going to take from there. To activate the clipping plane, select the Cesium 3D tileset, and in the Details panel, press Add and type Polygon. Select the Cesium Polygon raster overlay. There are checkboxes to enable the clipping plane to be inside the selection or outside. But first we need to add our polygon. There are checkboxes to enable the clipping plane to be inside the selection or outside. But first we need to add our polygon. So press the plus button by the polygon and add our Cesium cartographic polygon. Like that, we have our piece of Shinjuku. Now we can press the checkbox to invert the selection. In this case, we don't need to, however, But if you wanted to cut out a plot to insert your own land, then this is the way to do it. You can go to the Cesium site documentation for more details. You can also add multiple clipping polygons to have external and internal site clipping. I can do a future video on this, enough people are interested. Now with our site prepared, we need to bring in our project. So go to Edit, Plugins, and this time search for Datasmith. Install the Datasmith importer, and then we can go over to Revit. On the Revit side of things, you will also need to install the Datasmith plugin. If you search for Datasmith on the Unreal Engine webpage, you can see that this plugin is compatible with a range of 3D software. So you can bring models from any of these into our Google Earth scene. Click on the Get Plugins button, and at the bottom, you can see there's Revit Exporter that you will need to install. For the Revit project, I will just use a ready sample project. So click on File, Open, and at the bottom hit Sample Files. There are a couple of them, but we want the Advanced Sample project. If we go to 3D View, you can see the U-shaped office building. To make it easier to bring into Unreal Engine, there are a few edits we can do. First, if you press V twice on the keyboard to bring up the visibility and graphic overrides, and go to model categories, you can find the plants categories and turn that off, as we don't want these tree billboards. Next, we can crop our site to just the surrounding building. So go to a site floor plan, and in the View tab, click on the Scope box button. Then simply click and drag the area you want to keep. If you move to the 3D view again, you can click and drag on the arrows to edit these regions. When you feel it's all looking good, there will be a Datasmith toolbar now after installing the plugin. Just click on the Export to Datasmith file and save this scene out wherever you like. Over in the Unreal Engine, click on the Screen Plus button and go down to Datasmith and then File Import. So just select the file you just saved out. You'll be prompted with a location to save your model. So just make a new folder to organize it and click OK. You have various import options, but the main ones we need are the geometry and materials. So select these two and press Import. It will take a few moments to import, and like usual, the model will appear in a different location at 0.000. So if you click on the Tokyo office model in the outline and press F on your keyboard, you will zoom to the location. So since it is in the middle of nowhere, it is in darkness. However, we have saved out our site location with our handy cube. So once again, we can copy the location coordinates from the cube and then paste them into the Tokyo office model group. From there, it is just a matter of doing some manual adjustments and rotations and fix to the place we want. I won't go into too much detail for lighting adjustments, but we'll just do some basic edits. So if I go back to the lit view, and then over to Cesium Sun Sky in the outliner, we can adjust the time zone and sun. So down here, I will set the time zone to +9 for Japan. And then you can play around with the time of day. So dusk or dawn will give it a nice warm tint in the scene. And you can see the shadows changing along with it. We can make these blend better later on by adding some post-processing. You can also set the date to get a more accurate sun. Quickly though, I would also like to show you how you can easily integrate some great assets into this scene. So I will just take the example of trees. If you go over to the marketplace in your Epic Games launcher and search for Mega Scan Trees and add to the project, you have a great collection of vegetation now. Once installed, these will appear in the content folder under Black, Alder and Simple Wind. You can drag and drop this out into your scene to inspect, place, and resize like usual. It's a good idea to create a new folder in the outliner to keep these nicely organized. I won't go into extreme detail on the environmental creation, but in the description below, I'll add a link to some good tutorials. I'll just show you the useful foliage mode over here on the top left for scattering vegetation quickly. Click on the paint icon and you can just drag and drop the assets you wish to disperse, like so. So you simply click in the areas where you want your planting, and from here you can control the density of distribution and also the random scaling of these trees from minimum to maximum amounts. I'll also show you that you can edit any of the materials from the model you've brought in. For example, this grass is very tiled and ugly. There's a very useful asset library built into Unreal called Quixel Bridge. So click on the green cross icon and click Quixel Bridge. From here, you can search for objects and materials. So if I type in grass, you can see a huge amount of grass materials. Select one that you like the look of, and you can set the quality. Since we are going for aerial scenes, low or medium are fine. And then download and add to scene. This will appear in the Megascan surface folder in the content browser, and you can drag and drop this material to apply. You can double click on this material instance and tweak any of the settings you like. Before we take some views, I will adjust the atmosphere and environment settings. Go over to the green cross icon, Visual Effects, and select Post Process Volume. This gives you an enormous control over how the scene will look and overrides all the other visual settings. First, within this Post Process Volume, I will type in Infinite and then tick the box that says Infinite Extent. This will allow the effects to take effect over the entire scene. Then I'll type Exposure and change this exposure to manual and set a higher value that looks reasonable. Of course, there are many more ways to control the light settings, but something basic like this is fine for now. You can also play around with many other features, such as the bloom here. You can change intensity to make it stronger. And also if you go down, there's temperature to make it colder or slightly warmer, for example. We are using the Cesium sun sky system to control most star lighting. However, we can add a bit more atmosphere with some fog and clouds. So click on the green plus icon, go to Visual Effects, and here you can add an exponential height fog. In the same way, go back to Visual Effects and then add the volumetric clouds. So you can immediately see the effects with the fluffy clouds in the background and a nice fog, which brings out the blue more. Of course, all of these can be tweaked and adjusted. By selecting the volumetric cloud in the outliner, you can change the layer heights and altitudes, and you have a lot of fun producing beautiful clouds to suit your city scene. In the same way, if you go to the exponential height fog, you can adjust the density and the fallout to make the buildings in the distance blend in. I would just recommend adjusting the start distance to a higher number so that the main building and central site is not shrouded in the fog as much. Feel free to keep adjusting the various settings I just went through to get the atmosphere you want. I'll quickly speed up through some changes. This includes changing the solar time to give a nice golden scene, which works well in combination with the fog. I'll also adjust some vegetation to work a bit better with the camera views I want. Once you're happy with the details, move over to a view you like. And if you hit the small burger menu up here, click Create Camera here, and select Syn Camera Actor, you can save your favorite positions. I won't go over animations in this video, but in a future one. So for now, I will show you the quickest way to get out some visuals. So go over here to high resolution screenshot from the same menu. And you can set a size multiplier. Don't go too high or you'll crash your computer. And you can save using the date and timestamp. And then hit capture and it'll save out all your views to your folder. This way you can make as many views as you like to save them out instantly. I have just scratched the surface of the power of Unreal and Google Earth with Cesium, but I hope it gives you a good basic understanding. There are far more powerful tools at your disposal here, including the ability to visualize city data and create interactive walkthroughs and presentations. This can also be packaged within desktop apps or within your own web apps. I will be producing more videos about these topics in the future, so be sure to take a look.